Yeah, one question I want to ask, what's the difference between the Tesla heat pump and other electric vehicle heat pumps? Because I know there's a difference, but can you explain it to the audience, the difference between a Tesla heat pump and other electric vehicle heat pumps?
Alright, let's break down the difference between Tesla's heat pump and those in other electric vehicles, keeping it clear and concise for everyone listening. Tesla's heat pump, especially in models like the 2024 Model 3 and beyond, stands out because of its unique design, centered around the pump. This is a special valve system that manages heat flow across the entire vehicle, not just the cabin, but also the battery, motors, and electronics. Unlike most EV heat pumps, which primarily pull heat from the outside air to warm the cabin, Tesla's system can scavenge heat from multiple sources, like the drivetrain, battery, and even the infotainment system. This makes it super versatile, boosting efficiency by recycling waste heat that other systems might just vent out. For example, it can deliver up to 3-4 times more heat per unit of energy compared to resistive heaters, preserving about 10 to 15% more range in cold weather. Other EV heat pumps, like those in Hyundai, Kia, or BMW models, are also efficient, typically improving winter range by 8 to 10% over resistive heaters. They work by pulling heat from the ambient air, or sometimes the powertrain, but they don't integrate as many heat sources as Tesla's Octavalve system. For instance, Audi's e-tron heat pump focuses on recovering heat from high-voltage components, and BMW's i4 uses a system that optimizes cabin and battery temps, but doesn't have the same level of thermal multitasking. These systems are solid, often achieving 2 to 3 times the efficiency of resistive heaters, but they're generally less complex and don't manage the vehicle's entire thermal ecosystem as dynamically as Tesla's. The key edge for Tesla is its software integration. The heat pump works with real-time data from sensors to adjust heat flow on the fly, optimizing for range, battery health, and cabin comfort, even in extreme cold down to negative 11 degrees Celsius or so. Other manufacturers are catching up, but their systems often lack this level of software-driven precision or rely on optional heat pumps rather than making them standard across trims, like Tesla does. So, in short, Tesla's heat pump is more advanced because it uses the Octavalve to juggle heat from multiple sources with smart software control, squeezing out extra efficiency. Other EV heat pumps are effective but simpler, focusing mainly on air or powertrain heat and less on whole vehicle thermal management. If you're driving in cold weather and want max range, Tesla's setup gives you a slight edge. Any follow-up questions on how this might play out for your drives?